All right, so here in this, again, as last time, we were looking at lines and how to graph them. And we also saw last time the standard equation of a line, the standard form of an equation of a line. It was ax plus by equals c, where a, b, and c are numbers, but a and b cannot both be 0. And the main thing is the exponents of x and y are 1. So in other words, you're not going to have something like x squared or y squared. You're not going to have anything like that with if here at least, you know, because we're going to graph lines. So the exponents of x and y are just going to be 1. You know, if you had x squared, what would happen is you would get a quadratic, a parabola. So the exponents of x and y are 1, and we're going to see how to graph that. So really, it boils down to getting 2 points that are on the line, plotting them, and then connecting them. You know, connecting the dots, so to say. So what I'm going to do with this example is illustrate that. And the 2 points I'm going to get are the y-intercept and the x-intercept. So for the y-intercept, remember what that means is you must get x equal to, you set x equal to 0. Then what you're going to do is you're going to plug in x equals 0 and solve for y. You're going to plug in 0 and solve for y. Right? So that's what I'm doing here, right? So 3 times 0 minus 4 times y plus 1 is 0. So the 3 times 0 is gone, right? And we get minus 4y plus 1 equal to 0, as over here. And now we just got to figure out what y is, but that's not so bad. You just solve for it, right? You just solve for it. Namely, we can subtract 1 from both sides, okay? Right? And we want to get y all alone, so we have minus 4y equals minus 1. But to get y all alone, we divide by minus 4. So we get minus 4y over minus 4 equals negative 1 over minus 4, right? And so when you do that, the minus 4's cancel. You get y equals 1 over 4. The minus signs cancel. You know, 1 over 4. And that's the same as just 0.25. So this tells us that this point, right, x was 0, 0.25, that point is on this line. And also it tells you that the graph crosses the y-axis at this point. So 0.25 is the y-intercept. For the x-intercept, it's the same idea. For the x-intercept, it's the same idea. Namely, you basically switch roles of the variable. So you set y to be 0, okay? And then you got to figure out what x is. So when y is 0, okay, you plug that in, and then the equation is just an equation in x. So you get 3x minus 4 times 0 plus 1 is 0. So from here, we get 3x plus 1 is 0. You know, 4 times 0 is 0, so that's gone. So we're left with 3x plus 1 equals 0. And so what do? We subtract 1 from both sides. Okay? And so we get 3x, right, is minus 1. Right? Because again, we have 3x plus 1 equals 0. We want to figure out what x is. So we subtract 1 from both sides. Right? We want to isolate x, so we get 3x equals negative 1. And then we don't want 3x, we want x, so we divide both sides by 3 to get x equals minus 1 over 3. which is the same as minus 0.33. I rounded the 2 decimal places kind of arbitrarily. You know, on the exam, well, not the second exam, but on an exam, I will tell you how many decimal places to round to. But this tells us that the x-intercept is negative 1/3, which is about negative 0.33, excuse me. And the line crosses the x-axis at this point. Okay, so we have these 2 points on a line. And again, once you have 2 points, you just connect the dots, so to say, by a straight line. And that's the line you get. So we get this. Okay, so that's what we have here. Are there any questions about that? Okay. Now, I'm going to solve this another way. From my experience teaching this class, most students like to get this as y equals something, you know, in slope-intercept form, and then they get 2 different points on the line. I mean, that's okay. It's just that to me at least, that's just more work. But if you want to do it that way, that's fine. So let's do that though. Let me just illustrate that anyway. So if you want to get y in terms of x, right? Well, you want to get y all alone on one side of an equal sign. So for instance, minus 4y, we can add both 4y to both sides, right? Doing so, we'll have 3x plus 1 on the left and 4y on the right. 3x plus 1 on the left and 4y on the right. Okay, then what I did was I interchanged both sides. So we get 4y is 3x plus 1. Okay. But again, we want to get y all alone. So what do? We divide both sides by 4, right? Because then on the left we'll have y. The 4's will cancel, and we'll get y equals 3x over 4 plus 1 over 4. And so we have our equation as y equals something. Y equals 3x over 4 plus 1 over 4. Now, what you do from here then, what you can do at least, is you can get 2 different points by just using 2 different x values. You know, for each x value, you get a corresponding y value. So for instance, if we take x to be 0, right, we can do that. And we'll get y equals 3 times 0 over 4, right? We replace x by 0. 3 times 0 over 4 plus a 4th. Okay, so this part's gone. This becomes 0. We get 0 plus a 4th, which is a 4th. So we get y equals 0.25. In other words, this tells us the point 0.25 is on the line. Although, I mean, we knew that already from before. And again, this tells us that 0.25 is the y-intercept, right? This is where the line intersects the y-axis. Because again, x is 0 here. Okay, that's 1 point. Again, you can use any x values you want for the points. You know, here I chose x to be 1, but you could have chosen -1, you could have chosen 2, you know, whatever you could have chosen. So if we take x to be 1, we get y equals 3 times 1 over 4 plus 1 over 4. And of course, that's 3 over 4 plus 1 over 4, which is 1. 4 over 4, which is 1. This tells us that 1 is on the line as well. So 1 is on the line as well. Okay, so we have our 2 points here. Connect them, we get the same line. Same line. Okay, good. Here, this one I actually drew using Desmos. So, okay. All right. Any questions on this? Okay. Let's do another one then. So this one we'll do as well. Let me just get the recording.